No one. All right, so do we have our practice test that we're working on? And everybody got some of the pictures drawn so we can go over this. But again, one of the key facts that people are messing up on the quizzes and tests and stuff like that is just drawing things properly. Okay? When you're drawing the points 3, 1, negative 2, 1, and negative 1, 0, you got to make sure you get those points in the right spot. Because I've got people who are messing them up. Like, for example, the point here is 3, 1 for A, but I get a lot of people who are like putting it up here at 1, 3 by accident. So be really, really careful about where you're putting your points to make sure they're in the right spot. Don't drop negative signs. Don't do things like that. Now, again, we have different types of transformations. Our transformations are translation, reflection, rotation, and dilation. 3 out of the 4 are congruence transformations, which means that that the figure we end up with is congruent to the figure we started with, exactly the same angles, exactly the same side lengths. And those are rotation, reflection, and translation. Dilation is the only one that doesn't give us congruence, right? Dilation enlarges or reduces. So I can combine as many congruence transformations as I want and still get a congruence transformation, but as soon as I throw dilation in there, it's not going to be congruent anymore. Just something to keep in mind. Another thing to keep in mind for the quiz is you will have the coordinate sheet, a little half sheet again that has the coordinate rule on it. And hopefully my battery survives the rest of this podcast so people can listen to it. All right. First set of problems, x, y, going to x, y minus 1. So what does that mean we're going to do with this shape? What's going to happen to it? It's a translation. What are we doing? Describe that to me. Down 1. How about right, left? Not at all. Okay, and when we draw our new points, what are we going to do? We're going to put our new points in and label them and then connect them. Because whenever we do a transformation of a shape, we pretty much do one point at a time. How about number 2? It was x plus 2y minus 1. Or if I put it in vectored form, it would be this.
Over 2, down 1.
Okay, over to which direction?
To the
right. Actually, the way this chalkboard's facing, that's west. That's my point. But you're right, it's 2 points to the right and 1 down. So 2 right, 1 down, there's A primed. 2 right, 1 down, there's C primed. 2 right, 1 down, there's B primed. And again, we label, draw. Nothing could be simpler than translation. Okay, very simple. Reflection. If it's reflection in a line other than an axis, or y equals x, we do actually have to draw the line in. This is a reflection of the line x equals 4. Now remember, x equals 4. This is the x-axis, x equals 4 right there. It wouldn't make sense to do a horizontal line. It has to be vertical because x equals 4. And again, the way we reflect things is 1 point at a time. B is right on the line of reflection, so B primed is in the same spot. C is 3 units right to the line of reflection, so I'm going to go 3 units left. There's C primed. A is 2 units left, so we're going to 2 units right. There's A primed, and D primed is going to be right there. So it's kind of a funky reflection in a way because it kind of reflects over on itself, but that's my reflection. Okay? If we're reflecting in the line y equals x, I can do it 2 different ways. I can either use a coordinate rule or I can do it physically. In fact, what I really recommend is doing it both ways and making sure you come up with the same solutions. So if I do it visually, for example, let's start with V. 1 diagonal, 2 diagonal, 3.5 diagonals over. So half diagonal, 1, 2, 3. There's where V prime should be. R, 1 diagonal, 2 diagonal, 3 diagonal, 4 diagonals. So 1, 2, 3, 4. That'd be R primed. Okay. And we could continue with that, or I could use my rule, which says for this type of y equals negative x, AB goes to negative BA. So 5, 2 would go to negative 2, negative 5. Did that happen? Negative 2, negative 5, sure enough. 4, 5 should go to negative 5, negative 4. Let's see, negative 5, negative 4, yep. So where would S primed be? S is at 6, 9. Where would S primed be according to my rule? Negative 9, negative 6. Oh, that's going to be right there. And T primed would have to be at negative 6, negative 7. So 9, 8, 7, 6, right there. And sure enough, when I connect my dots, I get what looks like a pretty good reflection of that shape. Okay? So again, you can use the rules, you can use the visuals, you can actually do both to double check to make sure that it's done correctly. Any symmetry in that word, madam? No. Okay? M-A-D-A-M has no symmetry. If it was M-A-O-A-M, it would have a horizontal line. That's okay. This is a tricky one. It's rotated 90 degrees clockwise around the origin. Clockwise. Now, normally when we rotate counterclockwise. This one goes clockwise. So if it's 90 degrees clockwise, that's the same as what rule for counterclockwise? 270 counterclockwise, right? Because 90 clockwise, whoops, 90 clockwise winds up there. Okay? 270 counterclockwise winds up exactly the same spot, same rotation. It's just that if we're going to use one of our rules, I have to use the 270 rule. And again, using the 270 rule, I can very quickly find J primed. We switch B and to negative A, so negative 3, 3. Where would K primed be? The B, negative 3 comes first, and then the opposite of A. L primed is going to be at B, opposite of A. And M primed is going to be at B, opposite of A. And I could just plot those points. Negative 3, 3 for J primed. Negative 3, 3. Negative 3, negative 7 for K primed. L primed is at negative 7, negative 6. And M primed is at negative 7, 2. That should be my rotation. I can check it by physically rotating 90 degrees. Oops, I must have been off by one.
Close enough.
What'd I do? Oh, I got my coordinates wrong here. I'm sorry. It's negative 2, isn't it? I think I drew it wrong to start with. Yeah, I got my coordinates wrong here. So if actually we took this, yeah. Principle's the same thing. I got my coordinates wrong. J primed is actually at negative 2, negative 3, negative 2. Sorry. This would be negative 2, 2, 2. There's our problem. Okay. So it should be there and there. Better. Okay. Geez, really, it's super easy to miscount, isn't it? Okay. Rotational symmetry. Pentagon. 5 sides, yeah.
Rotation to 72 degrees.
Okay. So, how do we come up with 72 degrees? 360 divided by the amount of times it's going to be rotating to get to the same point. So 360 divided by 5 equals 72. However, 72 degrees by itself is not my answer because there are multiple rotations that give me this. So I could say this a couple different ways. You could say rotations of 72 degrees, that'd be fine. Or you could just say every 72 degrees. Or you could list the angles actually, 72 degrees, 44 degrees, 216 degrees, 288 degrees. Those would all be their rotations. And 360, of course, would be the next one, which is back to 0. So that's not even really a rotation. So you could say every 72 degrees or this, but don't just say 72, because that to me tells me you found one rotation and I want to find all of them. If you say every 72 or multiples of 72, something like that, that's acceptable. How about cross, number 8? 360 by 4, which is 90. So how would you state that then? Every 90 degrees, or you could list them as 90, 180, 270. Either way. But not just 90, right? Just 90 wouldn't tell me enough. I need to hit something. If you every 90, that tells me something different. All right, 10. Composition of dilation and translation result in the congruence transformation. Is that true or false? Why? Why is it false? Because dilation is not a congruence transformation. Dilation is similarity. So that's false. 11, composition of a translation followed by reflection and rotation is congruence. True. In fact, I could do three reflections, 6 rotations, a translation, another rotation, then another translation, and I'd still have congruence because there's no dilation involved. Dilation is the only one that violates congruence. Graphing the shape and its image. Now, again, it really helps if you have multiple colored ink or a pen and a pencil or something like that to really distinguish between the original and the copy, besides just drawing it. I mean, I can draw my points. J is at 2, 2. K is at 0, 2. And L is at 4, negative 2. Okay? So there's my original. Now I want to dilate this with K equals 1/2. Now dilation is super simple from the number standpoint, because what are we going to do? Multiply what? Things. Multiply things, okay. All of them? Every single coordinate gets multiplied by 1/2, right? So J prime's at 1, 1. K primed is at 0, 1. L primed is at what? 2, negative 1. I can graph that. J primed, K primed, and L primed. And sure enough, I get a reduction of my original. What if we're doing the next one where K equals 2 for the original? Then J primed is at 4, 4. K primed is at 0, 4. And L primed is at 8, negative 4. So again, 4, 1, 2, 3, 4, 1, 2, 3. There's, which is that? J primed. K primed is at 0, 4. And L primed is at 8, negative 4. Okay? And it's pretty clear to see that they're the same shape, just enlarged and reduced. So doing it coordinate-wise is super simple. Then you just got a graph. 15. This one's kind of interesting. For 15, it says, describe the similarity transformation. Now, the easiest way to do that, if it's just a similarity transformation, if it's just similarity, all we have to do is find one pair of corresponding points and find what went on. So A here is at negative 3, negative 1. And A primed, the image of A, is at 9, 3. When I look at that, did I multiply both of these by exactly the same, both coordinates by exactly the same number? What number is that? -3. So I can tell you this is a dilation, K equals -3. Because I can tell I divided them both, I multiplied them both by the same number. Now, it's important that K equals -3 and not -1/3. I know this is the original and this is the image. So it's important to note that. 16 was a little tougher because there's two things going on there, not just the dilation. What else is going on in that picture, 16? Also a reflection. So if I start out by reflecting W in the axis we are at, looks like 1, 1. Flipping over the y-axis would be a -1, 1. So we start with the reflection in the y-axis, and then W double primed is at -2, -2, 2. So what's my dilation? No. We started with a reflection, and then we have the dilation of 2. So we reflect in y-axis, and then dilate, K equals 2. That's a tough one. 16 is a hard one. 17. Whoops. There's our picture. It wants me to do two things. Reflect across y equals -1 and then translate it. Where's the line y equals -1? Is that an up and down line or a cross line? Across at -1. Okay, so we start by reflecting. 1, 2, 3 down, so 1, 2, 3 more down. There's J primed. S is 1, 2 up, so 1, 2 up. There's S primed. B is 1 and 1, so B primed. That's pretty easy. What's the next step? Translate at what? X minus 1, Y minus 2. So every point goes left 1, down 2. Left 1, down 2. And left 1, down 2. Yep. Yep. And it helps, like I say, to have the colors and stuff like that to do it. But as long as, what am I doing every time I draw a shape? I'm always labeling the points, right? First shape just has 1 prime, second shape has 2 primes. Number 18, I'm going to do it, we would have to graph it, but I want to do it without graphing. My points are as given there. N is at 2, 0, X is at 3, -4, Z is at -2, -3. Okay? First translation is 3 left, 1 up. So that would be XY. 3 left would be X minus 3. I'm sorry, shouldn't have parentheses there. There we go. And 1 up. So I'm very easily writing N primed is going to be 2 minus 3, which is -1. 0 plus 1 is 1. X primed would be where? Using this rule. 0, -3. And Z primed is -5, -2. Okay? Next it says rotation 90 degrees. Rotation 90 degrees, if it doesn't give us a direction, we assume counterclockwise. So I look up, I say counterclockwise 90 degrees. That's AB to -BA. So if that's the case, then N double primed is from -1, 1, we take that B, bring it to the front, but change the sign. And A just flips over to the other side, so -1, -1. X double primed would be what? 3, 0. And Z double primed would be at 2, -5. And from there, we could very quickly and easily graph those points, couldn't we? And again, we were able to do all those transformations just by using the rules. Didn't need a picture for that, although certainly we could do it with a picture as well. But especially for the rotations, I think the rules are usually much easier to follow. Just be careful, okay? Do not rush. The key to success in this quiz is not rushing. Because you saw, I mean, even I miscounted something and had the wrong number there because I just was rushing. I admit it, I worked too fast. Don't make the mistake I made. Be better than me. Okay? Again, you will be given this sheet with the rules on it, but that is basically what you can expect on your quiz.